Good evening, guys. Good evening, everyone. Welcome to the session. Today, we'll be starting a new topic, permutation combinations and probabilities. We've already completed number systems, and I hope you have gone through certain basics of permutation combination probability. But we'll still cover certain basics, and then we'll start with PYQs. Good evening, Himanshu. So we'll wait for another 30-40 seconds for people to join, and then we'll start the session. Since I'm covering the basics, very basics, I don't want people to miss anything. I hope you are solving questions after now attending the sessions, because the PYQs are not sufficient. You have to solve more questions of particular topics. Please solve at least 30 to 50 questions per topic. Okay, we'll start with the basics now. So permutations, combinations are nothing but a way to count a subject that that deals with counting, and to make the life easier for people who are counting, permutation combinations were introduced. So the very basic principle of the permutations combination is the basic fundamental principles of counting. So what is, we'll go through the basics. The first thing is the fundamental principles of counting. The first is, in this, under fundamental principle of counting, the first is the product rule. So let's take a problem here. I'll just illustrate the rule using a problem. So let this be Delhi, and then you have Bombay, and then you have Bangalore. So if there are two ways to go from Delhi to Bombay, and there are two ways from Delhi to Bombay, and Delhi to Bombay, and 1, 2, 3, 4, 4 ways from Bombay to Bangalore. So if there is this type of case, and you have to find out in how many ways a person from Delhi can go to Bangalore via Bombay. Number of ways a person can go from Delhi to Bangalore via, that is, he has to go through Bombay, is given by, is equal to the number of ways that a person has to go to Bombay, that is 2, into the number of ways from Bombay to Bangalore, that is 4. So that is 2 4 2s or 2 4s are 8. There are 8 ways for a person to go from Delhi to Bangalore via Bombay. This is the product rule. If they are giving you different number of ways for individual steps, and then they are asking you to find the number of steps for the combined route, then this is the product rule is the way to calculate the answer. The next rule is the addition rule. Here what we do is, for example, in the same problem, if a person is already in Bombay, if the person is in Bombay and he has to go to Delhi or Bangalore, if he has to go to number of ways, if he has to calculate the number of ways in which he can go to Delhi or Bangalore. In this case, what we do is we add the numbers. So for example, from Bombay to Delhi, there are 2 ways, and from Bombay to Bangalore, there are 4 ways. The total number of ways to go to Delhi or Bangalore, and please be very careful about this word. This is or. When there is or, you have to add the possibilities. This is 2 plus 4 is equal to 6. There are 6 ways in which a person can go from Bombay to Delhi or from Bombay to Bangalore. There are total 6 ways. So these are the 2 fundamental accounting principles. That is the product rule and the addition rule. Then we'll go through the permutation and combinations. So if there are 3 people, A, B, C, A, B, C. If we have to select 2 people out of these 3 people, if we have to select 2 people out of these 3, so here there is selection, but there is no order. In this case, this is called combination. We have to choose 2 out of 3. This is called combination. And it is represented by C. And if there are n people and we have to choose R out of n, R people out of n people, then it can be represented as NCR, and the formula is n factorial divided by R factorial into n minus R factorial. So this is the formula for selecting R people or choosing R people out of n people. And when you are choosing people without considering the order, that is called combination. So please this is combination. You are choosing people and there is no order. I hope this is clear. Next is permutation. So in the same example, if there are two spots, one for captain and another for vice captain, and then out of the three, we have to select two people for the two posts. For the two posts or two positions. So in this case, we are not just choosing the people, we are also choosing whether they become captain or whether they become vice captain. So this is called permutation. This is called permutation, or this is called arrangement. So in this case, if you are, so for the formula, if there are n objects, if there are n objects, and we have to arrange r objects at a time, the formula is given by NPR, that is equal to n factorial divided by n minus r factorial. This is for the arrangement. In this case, the order is also important. You have to select R people, and the R order and the R people have to be arranged in an order. For example, in this case, in earlier case, we selected two people. In combination, we selected two people out of the three, and the order was not important. We just wanted two people. So in this case, there were three people and we wanted to select two people. Here this would be 3 factorial divided by 2 factorial upon 3 minus 2 factorial is 1 factorial. This is three ways. Could do this in three ways, that is AB, BC and CA. These are the three possibilities. This is called combination. You are choosing two people out of the three people, and the order in which you are selecting, that is A, you can select B first and then A first, A second. This can be CB, this can be AC. It doesn't matter. This doesn't matter. These both are same. These both are same. BC and CB is same. CA and AC is same. This case is called combinations. Whereas in permutations, order is important. So if you have captain and vice captain, so A as captain and B as vice captain is a different combination, and B as captain and A as vice captain is a different combination. So in this case, if we are selecting three people for two spots, then the number of ways in which you can do it is 3 factorial divided by 3 minus 2, that is 1 factorial. This is equal to 3 2s are 6. You can do it in 6 ways. Or there is one more way in which you can calculate the permutations. That is the slot method. So what you have to do is, you have two slots, that is for captain and vice captain. So you have to write the slots here like this. This is captain, this is vice captain. So if we have three people here, so for the captain we have three possibilities, three people who can be captains. And once the captain is decided, then there are only two people left out for vice captain. So this will be 2. And you have to multiply this. 3 into 2, that is equal to 6. This is the slot method. This is the same. Instead of using the formula, you can use the slots and calculate the values. And even here, you have a different method. I mean, you have one more method. The same thing. Finally, you would get the same here. For example, if you have 3 people, I'll cover this combination, different way of calculating combination later. It will confuse you. I hope these two are clear. Permutation, combinations. What is a combination and what is a permutation? If you have any doubts, please ask. Till now, if you have any doubts of whatever I've covered. If it's clear, please let me know. I'll move to the next section. Okay. See, for example, in slot method, there is arrangement. For example, if there are 4 different flowers, let us call it F1, F2, F3, and F4. These flowers have to be arranged in a row consisting of 2. There are 2 spots in a row. So now you have to arrange these 4 flowers in these 2 places. So this place, the first place, in the second place. In the first place, you have 4 choices: F1, F2, F3, or F4. So there are 4 possibilities here, 4 flowers which you can put it in this slot. And the next slot, once you have put 4 here, so there is only 3 flowers left to be placed in the slot 3. Sorry, in the slot 2. There are 3 slots. The total ways of arranging these 4 flowers in 2 spots is 4 3s are 12. I hope that this is clear. This is the slot method. Similarly, if there are 3 slots and you have to arrange this 4 flowers, so 4 into 3 into 2 is 24 ways. Is this clear, Diti? Okay. So if you have any doubts till now, please ask, or else we'll move to the next section. Okay. Now, permutations of things when some are identical and some are identical. For example, if the word, let me take a word, HASSAN. So this word is made up of 1, 2, 3, 4, 5, 6 alphabets. And if they ask you in how many ways can the alphabets be arranged? In this case, when there are here there are alphabets that are repeating. So A is there are two A's and there are two S here. In this case, what we do is we count the total alphabets, that is 6 factorial, and then divide it by the repeated ones. So there were two A's, so 2 factorial, and 2 S's, so another 2 factorial. So this would be 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1 into 2 into 1. 2 and 4 cancels. 5 is a 30, 33 is a 90, 92 is a 180. This is 180 ways in which the word Hassan can be arranged. Similarly, for a generalized formula, this is for a specific example. For the generalized formula, if out of n things, p are exactly same, alike, of one kind, q are exactly alike of second kind, and are exactly alike of third kind, and the rest are different. Then the number of permutations of n things taken all at a time is given by n factorial divided by p factorial divided by q factorial and r factorial. This is p factorial into q factorial into r factorial. This is the formula. Please remember this. So in this case, same formula, we have used the same thing. There were 6 words, 6 alphabets. 2 were of the same kind, and then again 2 were of the second kind, AA and SS. So 6 factorial divided by 2 factorial and divided by 2 factorial again. I hope this is clear. So if you have any doubts, please ask. So in this case, there were only two of a particular kind that was repeating. But in some cases, there would be other ways. For example, you take the word successful. SUCCESFU. Well, if this is the word successful, if you want to calculate in how many ways this can be, this word, alphabets of these words can be arranged. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 alphabets. And P, C is 2 times. C is there 2 times. C 2 times. And S is 3 times. S is 3 times. And U is 2 times. 2 times. Here, if you want to calculate the number of ways it can be arranged, is 10 factorial divided by 2 factorial, 3 factorial, and 2 factorial. This is the R that I was speaking about. I mean, this can continue like anything. I mean, if you have any other element that is common, that are similar, that is repeating, then you have to divide it by that factorial. So here, C, there are 2 C's, 3 S's in this word, and 2 U's, this U and this U. The total number of ways of arranging these things, these alphabets, is 10 factorial divided by 2 factorial, this 2 factorial, this 3 factorial, and this 2 factorial. And this is the total ways in which you can arrange. I hope this is clear, LKR. If there's any doubt, please ask. I mean, and this arrangement is also called anagram. It is also called anagram. Anagram is nothing but rearrangement of letters in a word. So if they ask you what are the number of anagrams that can be formed, so this is the same thing, arrangement of these alphabets of a word. Is this clear? Okay. Then about combinations. So I told you that there is one more way of to calculate the number of ways you can choose people. For example, if there are 10 students, and 3 students are to be selected, like a team of 3 students should be selected for a debating team. So in this case, there are 10 students and 3 students should be selected out of 10. So this can be done in like this, 10C3. This is equal to, you can use the formula there. It is 10 factorial divided by 3 factorial into 7 factorial. This formula. NCR is equal to n factorial divided by r factorial into n minus r factorial. This is one way of solving this. The another more intuitive or more natural way is to say, out of these 10 people, 3 people has to be selected. So out of this 10, I mean, if there are 10 people, 3 would be selected and 7 would be not selected. 7 students will not be selected. So this is nothing but you have to calculate the anagram of this thing. The number of ways of doing this, arranging this is total 10 factorial divided by these 3 s, that is divided by 3, and these 3 not selected, and these 7 not selected. 7. These 2 are same. You can do it using this formula, or you can do it using this intuitive way. I hope this is clear. If you have any doubts till now, please ask, or else I'll move to the next part. Okay. Now we'll move to the probability part. What is the probability? Probability of an event. Probability of an event is equal to number of favorable outcomes divided by number of all possible outcomes. Number of favorable outcomes divided by number of all possible outcomes. If an event is absolutely sure to happen, sure to happen, then the probability of that event equal to 1. So the probability, and if an event is absolutely not going to happen, if an event is not going to happen, then the probability of that event is 0. So the probability varies from 0 to 1. It's a number between 0 and 1. I hope this is clear. So if you are calculating probability of any event, that is equal to number of favorable outcomes divided by number of all possible outcomes. And if an event is absolutely sure to happen, the probability of that event is 1. And if an event is not going to happen, then the probability is 0. And the probability varies between 0 to 1. I hope this is clear. If you have any doubts, please ask. For example, if you toss a coin, and you have to find the probability of the coin showing heads. That is, there are two possibilities. Total number of possibilities is 2, and the possibility of getting head is 1. There is one face with head and one face with tail. So the probability is 1 by 2. 1 is the number of faces that is there, heads. And then there are two possibilities, overall possibilities. That is one head and tail. That is 2. This probability of falling a head when you toss a coin once, that is 1 by 2. Similarly, if there is a cube or a dice, so number of possible, there are 6 faces numbered 1 to 6. 1, 2, 3, 4, 5, and 6. So if they ask you to calculate the probability of any even number occurring, when you roll a dice. So so you have to calculate the number of even numbers, that is the possible favorable outcomes. 1, 2, 3. There are 3 even numbers. 3 is in the numerator, and the total possibilities, that is total number of possibilities that can occur, that is there are 6 possibilities. 1, 2, 3, 4, 5, 6. 3 by 6, that is 1 by 2. So this is for probability of even number occurring when you roll a dice, that is 3 by 6, that is 1 by 2. Half. I hope this is clear. If you have any doubts, please ask. It is clear. If you have any doubts, please ask. Okay. Next, we'll cover certain basics of this thing. So in this case, a coin has 2 faces. The dice has 6 faces. And then there are cases where they ask you about cards, playing cards. So in this case, please note down the basics here. There are 13 cards. Of each suit. So in one suit, I mean, there are two reds, this diamond, hearts. These two are red. Diamond and heart is red. And there are black cards. There is spade and clubs. There is spade and clubs. So these are 4 types of suits that are there. And in each suit, and for example, in diamond, there is 1 ace, 3 face cards, that is king, jack and queen, 1 ace, 3 face cards, and 9 number cards. 9 number cards. For each of these diamond, hearts, spades, and clubs. So for each of this, there is 1 ace, 3 face cards, and 9 number cards. 3 face card is king, queen, and joker. There is 1 ace, and 9 number cards, that is 1 to 9. 1, 2, 3, 4 till 9. And sometimes they ask you to calculate the probabilities of this. So just know the basics, and once we solve questions, you would understand this. So I hope this is clear. If we'll start with the problems. If you have any doubts till now, whatever things that we have covered till now, you're free to ask. Please feel free to ask if you have any doubts before moving to the problems, the PYQs. Is this clear? Okay. So we'll move to the questions then. So we'll start with the PYQs. So please take 2 minutes to solve this question. Please post your answers. So there is one response for option D and 2 people have got option B, that is 6 and 18. Others who are solving it, please post your answers. Okay. We'll see how to go about this question. They're saying with reference to the figure given below, the number of different routes from S to T, this is S and this is T, without retracing from U and or V. So they are not coming back again. They are just going from this, from S to T. There is no reversal. There is no retracing. The number of ways is, so we have to calculate the number of ways. The number of ways from going from S to U. I mean, there is no other way to go to T. You have to go to U and then you have to go to V and then you have to go to T. The number of ways of going from S to U is 1. This is one way. This is 2 and this is 3. There are 3 ways to go from S to U. And from U to V, there are 2 ways, 1 and 2 And V to T, there are three ways, 1, 2, and 3. So the number of ways of going from S to T is 3 into 2 into 3. It is 6 3s, 3 2s are 6, 6 3s are 18 ways. I hope this is clear. For people who have got option B, if you have any doubts, please let me know. The correct answer is option D, 18. So from S to U, there are three ways. This is from S to U. And this is U to V. And this is V to T. Then you multiply this. Is this clear? If you have any doubts, please ask. If things are clear, I will move to the next question then. If it's not clear, if you have any doubts, people have got other options like B and C, you may ask your doubts. Okay. So they're asking, in how many ways can a person go from S to T? So these are the routes that they have given, and without retracing from U or V. So you cannot go back from U. So if you go from this route, and then you cannot take this route back again. You cannot go back. This is not possible. You have to go in one direction from S to T. So from S to U, there are three ways, 1, 2, 3 ways. And from U to V, there are 1 and 2 ways. And from V to T, there are 3 ways, 1, 2, 3. The total number of ways from S to T is 3 into 2, 3 into 2 into 3. That is 3 2s are 6, 3s are 18, 18 ways. I hope this is clear. If you have any doubts, please ask, or else we'll move to the next question. We'll move to the next question then. So take 2 minutes to solve this question. Please post your answers. There are 2 responses for option D. Others, please post your answers. Okay. We'll see how to go about this question. What they're asking is 12 people form a club. 12 people form a club by picking lots. One of them will host a dinner for all once in a month. The number of dinners a particular member has to host in 1 year is. So they are saying that there are 12 people, and by picking lots means it is like a lottery. So they'll put the 12 person's name, and if they pick one name, that person has to host the dinner. And they're saying how many, the number of dinners that a particular member has to host. See, every time, every month, when they're picking the name, it will be different. The probability is different. And you cannot say how many dinners that a person will host. For example, if there are A, B, C, D, if there are 4 people, I mean, in this, I'm just taking an example, and all the 12 months, they can pick only A's name. This is purely by chance. I mean, you cannot say for sure that B or C or D will come. They can only, these 2 people will, I mean, when you put these A, B, C, D names in a chit and you pick a name, so there is a possibility that all the 12 months, only A's name come, and only A has to host the dinner. So we cannot say for sure how many number of dinners that any person will have to host. So the only thing that we know is the probability is 1 by 12 for each candidate for a month. I hope this is clear. This is option D. It cannot be predicted. If you have any doubts, please ask. Else we'll move to the next question. Calculating the probability and calculating the number of dinners are 2 different things. Shweta, is this clear? Okay. So we'll move to the next question then. Take 2 minutes to solve this question. Take 2 minutes to solve this. It's time. Please post your answers. There's one response for option B, 12. One for option A. Others, if you are solving, please solve it quickly and post your answers. What about others? Geeky, Prajwal, Tam, Beetle. Please post the answers if you have got the answer. If you are doing it, please post it. Himanshu, are you there? If you have done, if you have solved it, please post. We'll see how to go about this question. I hope you have tried at least solving this question. We'll see how to go about this. So a selection is to be made for one post of principal and two posts of vice principal. Amongst the 6 candidates called for the interview, only 2 are eligible for the post of principal, while they are all eligible for the post of vice principal. The number of possible combinations of the selectees is 4, 12, 18 and none of the above. There is one post for principal and 2 posts for vice principal. And they are saying there are 6 candidates. Total candidates is 6. 6 candidates. And out of this 6, only 2 are eligible for the post of the principal. Only 2 are eligible for the post of principal. So for principal, there are only 2 people that can be selected. So for choosing this, there are 2 people, that is 2C1. You have to choose 2 people for the one post here. And then, and while they're all eligible for the vice principal post. So now they are saying that all 6 are eligible for vice principal post. But here we cannot take 6C2. We cannot take 6C2 because once you select the person for this principal post, there are only 5 people left out. Out of this 5, we have to select 2 people for a vice principal post. And this vice principal post is, there is no order. There is no differentiation between the 2 posts. So this is the number of ways in which you can do this. Select these 2 people are IC2. And the total number of ways in which you can select these people as vice principal and vice principal is 2C1 into 5C2. This is 2 into 5C2 is 5 factorial divided by 2 factorial into 3 factorial. This is 2C1 is 2 itself. This is 2 into 5 into 4 into, I can write it as 3 factorial divided by 2 into 1 into 3 factorial. This 3 factorial and 3 factorial gets cancelled. 2 and 2 gets cancelled. 5 4s are 20. There are 20 combinations or 20 ways in which you can select the selectees. The correct answer is 20 is not here, so the option is D, none of the above. I hope this is clear. We have to be very careful when you are doing this permutation combination probability questions. One silly mistake, you will not even know that you have made a mistake. I hope this is clear. If you have any doubts, please ask. See, 3 factorial is the formula. Like even if, for example, out of 5 people, if you have to select 2 people, selecting 2 people and not selecting 3 people, this can be done as 5 divided by 2 factorial divided by 3 factorial. Or if you use this formula, pi C2 is 5 factorial divided by r. This is r, this is n. N factorial divided by r factorial divided into n minus r factorial. R is 2, 5 factorial divided by 2 factorial, n minus r is 5 minus 2 is 3 factorial. Is this clear, LKR? Why 5 factorial divided by 2 factorial and 3 factorial? If we take VC, vice principal, Prajwal, I not understanding your question. See, whenever you are trying to solve here, you have to first consider the most restricted one. The post of the principal is the most restricted one. Vice principal, all the 6 people can become vice principals for 2 posts. In the principal, only two category people are allowed for the principal. That's why we will consider the principal first and then vice principal. I mean, this is the rule that you have to start with the most restricted one and then go to the least restricted one. I hope this is clear, Prajwal. If you have any doubts, please ask. Okay. So then we'll move to the next question. So take 2 minutes to solve this question. It's time. Please post your answers. There are two responses for option A. Others, please post your answers. A is 5. There are 3 people who have got option A. Others, if you are solving, please solve it quickly and post your answers. We'll see how to go about this question here. A student has to opt for 2 subjects out of 5 subjects for a course, namely commerce, economics, statistics, and maths 1 and maths 2. These are the 5 subjects. 1, 2, 3, 4, 5 subjects which are there. And mathematics 2 can be offered only if mathematics 1 is also opted. So they are saying mathematics 2 can be taken, M2 can be taken only if M1 is there. So if there is M1, there is only, if there is M2, then there has to be M1. There cannot be any other subjects that we can take. The different number of combinations of 2 subjects which can be opted is. So if there is M2, there is only one subject that we can take, that is M1. So this is one way of choosing the subject. And then once this is done, if M2, we have to remove M2 because M2 we cannot select. Because if we select M2, there is only one subject that can come together with M2, that is M1. This is one way. So if we remove M2, because M2 has to come with M1, so we have considered that possibility, M2 and M1 together. That is one possibility. Now, when we are taking this 4 subjects, that is commerce, economics, stats, and mathematics 1. Because I'm leaving mathematics 2 because if we take mathematics 2, then mathematics 1 has to be the other subject. So that is one combination that I've counted separately. Now I have to select out of these 4 subjects, remaining subjects, C, E, S, and M1, I have to choose 2 subjects for C2. This is 4 into 4 factorial divided by 2 factorial into 2 factorial. This is equal to 4 into 3 into 2 into 1 into 1 into 2 into 1 into 1, 2 into 1 gets cancelled. 1s are 2, 2s are, that is 3 2s are 6 ways. So out of this 4 subjects, selecting 2 subjects is 6 ways. And this M1 and M2 and M1 together is 1 way. So this is total is 1 plus 6 ways, that is 7. So a student can opt these 2 subjects in 7 different ways. The answer is option C. I hope this is clear. Do not multiply this 1 into 6 because M2 and M1 combination is 1 way. is a one combination. And then there are 6 different combinations. Is this clear? I mean, nobody had got the right answer. If you have any doubts, please ask. Please clarify all your doubts. So in these type of questions, permutation, combination, probability, you have to practice a lot because you may not even realize that you have made a mistake. And don't directly jump to see the solution. Just if you're not getting, whenever you're practicing, if you're not getting, please spend some time. Think through different ways. Okay. So that is one way. And then you have to select out of the remaining 4 subjects, you have to select 2 subjects. That is 6. 1 plus 6 is 7. So others, if you have any doubt, please Prajwal, the LKR. If you have any doubts, please ask. Is this answer clear? I mean, solution clear? See, we add 1 because 1 is one way of choosing these 2 combinations. They are saying M2, Maths 2 can be offered only if M1 is also opted. So M1, you can take M2 only if M1 is there. So I'll just note down the combinations here. One is M2, M1. This is 1. Then you have M1 here. And then out of these 4 subjects, you have M1C, then M1E, M1S. Like this, you can note it down, the combinations. I hope this is clear. And then there is, if you take S, SC, and SE, there is, if you take E, EC. These are 1, 2, 3, 4, 5, 6, and 7. These are the 7 combinations that you can take. But if there is M2, there has to be M1. This is the condition that they have given. But if there is M1, you can take any subjects. EC means commerce, economics, or statistics. But you cannot take M2. I have taken it separately here. I hope this is clear. If you have no doubts, we'll end the session here. It's already 9:17. So we'll meet tomorrow at the same time, that is 8 o'clock. Please go through the basics that I've already gone through and solve a few more questions of this topic. Clearly, the number of questions that are there in PYQs are not sufficient. Please go and solve some more questions so that you get confident. And we'll meet tomorrow then. If there are no more questions, then we'll end the session here and we'll meet tomorrow at 8 o'clock. If you have any doubts, please feel free to ask. I mean, don't do this listing in the exam. This is just for illustration purposes that I'm doing. Don't do this in the exam. And if, for example, in this case, there are only 7 possibilities that you can write it down manually. But if there are more than 10 or more than 20, you cannot write everything down. And please be very careful with these questions. I mean, you can do many mistakes in these questions. Please be very careful. And only if you are very, very confident, attempt this question. Because if you attempt and if it goes wrong, you will get a negative. But solves many problems so that you are confident and your accuracy improves in this type of questions. So at least in probability permutation combination, if I tell for like other topics, if I'm telling you to solve 50 problems, here at least solve 100 problems, twice that of the normal problems that you do. In the examination hall, you cannot know correctly whether you have. Sometimes, if you don't get the answers which are there in the options, then you will clearly know that this is not the correct answer. But there is, I mean, very difficult. I mean, it's very difficult to know that we have made a mistake. That's why while you're practicing, please ensure that you're following each and every step clearly and don't make silly mistakes. In while you're solving, practicing, you will only come to know that you have made a mistake only once you see the solution. I mean, if you have solved it and if you have got this option, one of the four options as answer, then you would think that that is the correct answer. But when you see the solution, the answer would have been different. And this happens many times in probability permutation combination questions. So please be very careful. And to improve your accuracy, please solve more questions. So I think we'll end the session here if there are no more doubts. So we'll meet tomorrow at the same time, 8 o'clock. And please go through the basics again and also solve some of the questions. At least 10 to 20 questions separately that are there in other books. And then attend the tomorrow session. I hope the sessions are useful. Thank you for coming and have a good night. Thank you.